let's look at application of trigonometry. Now the simplest application is to find the height. This is the simplest kind of application. Basically you have something here. It could be a building, it could be any kind of tall structure, it could be a tree. Now you measure this angle and you measure this distance. Remember, this distance you can measure. Now to find this height, just try to figure out which particular trigonometric ratio is required. Now in this case what happens is opposite side is involved and the adjacent side is involved. So opposite and adjacent basically means tan. So this becomes tan 30 equal to h by r. Now to find h, you just take the h by d, right? D to the other side. So d tan theta, right? So let's say this is 30 feet. Then this would be 30 into tan theta, tan 30. Now tan 30 is equal to what? Again, if you really don't have to remember this. So just remember cos is 1, sine is 0. So 4 by 4, 0 by 4. So which means 30 degree would be what? 3 by 4, 1 by 4. So 30 times sine theta by cos theta. Sine 30 by cos 30. So this becomes 30. Sine 30 is 1 by 2, right? 1 by 2 divided by cos 30 is what? 3 by 4. So root 3 by 2. So this becomes 1 by 2 into 2 by root 3. 30 by root 3, which is 30 root 3 by 3. So 10. So this becomes 10 root 3. Yes. Okay. Now that is the simplest one. So where you have basically 3 variables. You have the angle, you have the height, you have the distance. So here you have got 3 variables. 2 will be given and you have to find the third, right? Okay. Depending on which one is asked, you have to choose the appropriate trigonometric ratio. Okay. Now another type of problem that might be given, it boils down to a diagram, right? So something like this. Now remember, these things will be given to you in a descriptive form, right? You have to read that problem statement, you have to understand it, and you have to draw the appropriate diagram, right? So here this angle is given, this is given, right? And you have been asked to find the height, got it? And the distance is given. So now here it's a little, looks very complicated, but it's not. What you do is since this distance is given, this is given, alpha angle of depression is given. Remember, this line is parallel to this line. So that means this is also alpha, right? So now what happens is you can use, say, h1. So this becomes h2. Since this is h1, this will also be h1. What happens here? You can use h1. h1 is equal to, again, tan theta, opposite by adjacent side. So d tan alpha. Yes. Now that you have h, you have to find h2, right? Now h2 itself you don't know. No, you can calculate. So h2 would be what? Remember, this is distance, This is parallel to this. So this will also be D. So which means what? H2 will be D tan theta. And this is H1. So H will become what? H1 plus H2. Yes. Okay. Now another type of problem. So here the context could be what? What kind of problem might be asked? You are standing on top of a building. There is another taller building here. From the top of this smaller building, you find the angle of elevation, find the angle of depression, and you find out the distance between these two buildings. Now, based on that, you have to find the height of the other building. Yes. Okay. Another type of, see again, instead of building, it could be something else. So, you need to understand the problem. Okay. Another type of problem that might be asked is something like this. See, usually these problem statements, what the authors of this, what they will do is they'll create a diagram first, and then what they will do is give a story to it. Once they have created the diagram, they have identified the various details, and then they will put a story on top of that, right? So you have alpha, beta, right, and the distance from here to here. Okay, now you have to find the height. Now this may be given in a slightly different way, in the sense the person who is measuring these things, he finds the angle here, then moves back and finds the angle again to the top of this object, right? So he knows this D. Now what you are being asked to find is this D. D2 is to be found, right? Now this D is not really required. Now why this type of a situation? Because this is something that can't be measured directly. This can't be measured. It might be a river, it might be some kind of a place where you can't directly measure it. Okay, so in this case what happens, right? Remember, in both the cases, whether it is for alpha or beta, this height remains the same. So H becomes what? Beta tan alpha. H equal to alpha tan, no, sorry, not alpha tan. This is, let's say, total distance is D. D tan alpha. No, D tan beta. Yes, D tan beta. Again, H is equal to D1, D2, D2 tan alpha. Yes. Now remember, this is equal. That means the right hand side should also be equal. So this becomes D tan beta is equal to D2 tan alpha. Right? So since angles you know, do you know D2? Now D2 can be written as what? D minus D1. Yes? D minus D1. Now D1 we can measure. We can measure D1. So you have D tan beta, D tan alpha minus D1 tan alpha. Yes. So D tan beta minus tan alpha. Yes. Divided by D1, which is equal to tan alpha. but D1 is what is required, right? No, D2 is required. Okay, no problem. So D1 is there, this we know. This D is what has to be calculated. So let's take tan alpha is equal to 1 by D. So D becomes equal to D1 tan alpha divided by tan beta minus tan alpha. By the way, since we have taken D to the other side, this D gets cut off. That is how again this step is carried out. By the way, another thing that I did was this minus, I have left it that side. So D1, if I take minus to this side, what happens here? I can take the minus on top or at below also. So here what happens? If I take it inside, what will happen? This will become minus and this will become plus. Or what I can do is, I can just exchange, leave this as minus and exchange this angles. So tan alpha minus tan beta. So this becomes like a standard formula for this type of problem. But the point is, you should not try to remember this, right? If you understand the concept, you yourself will be able to do it, right? So now that you know D minus D1 will give you D2, and this is what was required to be calculated. Okay, now another type of problem. Suppose on top of this building there is something, right? And you measure this angle and you measure this angle. Yes, so this is alpha, this is beta. Now what has to be found is this height of this pole or whatever. Now remember, beta has been calculated keeping this height in mind. Alpha has been calculated based on this height. So this is h1. This height is h2, height of the pole, right? So what happens? Take alpha. If you take alpha, h1 is equal to, now you know the distance here. This is distance is same for both. Yes, distance is same. So h1 becomes d tan alpha, right? And h becomes d tan beta. Now d is common, d is same, so take tan alpha to the other side. So h1 tan alpha equal to d, which is in turn equal to, this is h1, h by tan beta. Since they are equal, that means these two are also equal. So which means h1 tan alpha equal to h tan beta. Now what do we need to calculate? We need to calculate h. Yes, h and h1. So now remember, here you have two variables. One of them will be given. So height of this building is given. That means h1 is given. So since h1 is given and you have to find h, you will get what? h1 tan beta divided by tan alpha. Now that you have h, height becomes what? h minus h1. Another type of problem may be of this type. Say for example, you have a building and you have a taller building, right? And from the top of the taller building, you are finding the angle of depression to the top and bottom of the smaller building. Yes. Okay. Now this is, let's say, alpha, and this is beta. One trick here is to understand that this horizontal is parallel to this ground, right? This is D. So since this is parallel to each other and this is a transversal, so that means this is also alpha. No, this is also beta, alternate angles, and this is also alpha. Now if you have been asked to find this height, then it is a very simple problem. Why? You just have to find the height here, h1, and you have to find the height here, h2. Now h1 is equal to what? h1 is equal to what? h1 is equal to, or let's do it step by step. Tan alpha is equal to what? Tan alpha is h1 by d. So that means h1 is equal to d tan alpha. So you have h1. Now similarly, if you look at the other triangle, tan beta is equal to h by d, right? So that means h is equal to d tan b. Now do we have h? No, we don't know the height. But let us say we have been given the height of the smaller building and we have to find the height of the tall building at different scenarios. So in that case, what happens? We already know h1, we already know h2. So this h can be replaced by h1 plus h2. Let's say this is h. Now h2 is equal to h, which means this can be replaced with this h. So that means h becomes equal to d tan beta minus h. So our total height will be what? h1 plus h. Yes. Now if you have been asked to find the height of the smaller building, then in that case what happens? Then we would be given the height of the tall building. So either you will be given h2 or you will be given h. So in either case, you can solve this problem like this. Okay. Now another type of problem would be something like this. Let's say you are standing, let's say from here you are measuring the angle of depression, right? And you have to find this distance, right? Now this is the angle alpha, beta, angles of depression. Now you can't directly measure this distance, maybe because it's a river or something like that, and you're standing on top of the bridge, something like that. Now you can measure the height by dropping a rope or something like that. You can measure these angles. So now it becomes easy for you to find the distance. Let's say this is d1 and this is d2, right? So tan, remember, if this is alpha, this is alpha. If this is beta, this is beta. So tan alpha is equal to h by d1. Tan beta is equal to h by d2. d1 is equal to h by tan alpha. d2 is equal to h by, this is h by tan beta, right? Now it's just a question of adding it up. d1 plus d2 is tan alpha tan beta LCM, right? Tan alpha, h tan alpha plus h tan beta. Yes, now h is common, so take it out. Tan alpha plus tan beta by tan alpha tan beta. See, I'm actually doing this like a, as if I'm deriving a formula. But what you should look at is, while you are doing this, you would be actually putting the values. I would not recommend that you remember these formulas, because then how many formulas can you remember? Every type of problem will have its own formula. Okay, let's look at another type of problem. Suppose you are standing here and there is some object, a kite or a balloon is here, and you measure the angle of elevation. Yes, after some time, when you see it is here, and again you measure the angle of elevation. Let's say this is alpha and this is beta, right? Now what you want to figure out is, height remains the same, so you know the height. Let's say what you want to figure out is how much distance has it traveled in that time. Okay, again as usual, let's say this is capital D, this is D1, and let's say this is D2. We want to find D2, and this is h. Height remains the same, so here also it is h. So tan alpha is equal to h by d1. We already know h, so we actually want to find d1. So d1 is equal to h by tan alpha. Similarly, tan beta is equal to h by d2 plus d1. Yes, so actually this is capital D, right? So capital D is equal to h by tan beta, right? So now to find D2, remember D is equal to D2 D1 plus D2, D1 plus D2. So what happens? D2 becomes D minus D1. Now we have a formula for D1, we have a formula for D. So let's do it. Capital D is h by tan beta minus D1 is what? So let's simplify this. Let's take the LCM. Tan alpha tan beta, h tan alpha minus h tan beta. H is common to both of them, so let's take h tan alpha minus tan beta by tan alpha tan beta. Yes, looks very similar to the previous example. The only difference is here it is plus and in this one it is minus. So you need to be a little bit careful. Don't try to remember these formulas. Just look at it as problem solving, because if you start trying to remember all these things, every type of problem will have its own formula. Okay, in all these problems we have seen, I've been using some terms. One is angle of elevation, angle of depression, line of sight, and horizontal. Now suppose you are standing here and you are neither looking up nor looking down, you are looking straight, then that is called the horizontal. Now if you are looking at an object above this horizontal, then the line connecting your eyes to the object is called the line of sight. Similarly, if you are looking below the horizontal, then the line connecting your eyes to the object is called line of sight. The angle formed by the horizontal and the line of sight is called angle of, if you are looking above the horizontal, it is called angle of elevation. If you are looking down, it is called angle of depression. Yes. So these terms you should understand clearly, so that when you are reading the problem, you are able to convert it into a diagram properly. I think that's enough for today. Bye for now.